Thank you so much all for joining us on this fourth day of the 17th Vermont Organics Recycling Summit, organized by the Composting Association of Vermont in partnership with the Vermont Agency of Natural Resources. The summit this year is being held as a kickoff event for International Compost Awareness Week, which starts this Sunday on May 7th. And International Compost Awareness Week is the largest and most comprehensive education initiative of the composting industry. We've adopted that theme, and this year that's for healthier soil, healthier food, compost. And I just want to give a quick shout out to this poster on the right here, which is by a UVM student in Dr. Deb Nair's Composting Ecology and Management class. Each year, one of their class projects is for all the students to make their own versions of International Compost Awareness Week posters. And so we like to highlight those. The full collection, as well as the stories for inspiration from the students behind their poster creations, are available on the CAV website at compostingvermont.org/VORS. I'd like to thank all of our fabulous sponsors who allow us to bring this full week program to participants free of charge. We would not be able to do this without their support. This year, those include Community Bank, Nature Cycle, Eco Products, Vegware, Addison County Solid Waste Management District, AgriLab Technologies, Vermont Natural Ag Products, the Vermont Produce Program from Vermont Agency of Agriculture, Food and Markets, and RMI. So huge thanks to those folks. I'd like to introduce Emily Johnston, who's the Program Outreach Coordinator for Addison County Solid Waste Management District, who is our session sponsor, and let her just have a few minutes to say something about their programs.
Yeah. Hi, everyone. I'm very happy to be here and represent Addison County Solid Waste Management District on this call. We are very proud to sponsor this event as we help a lot with organics management in Addison County. We have 21 member towns. We do a lot of education and outreach with businesses, schools, and also the community in our town surrounding organics management. And we do also operate a transfer station in Middlebury where residents and businesses are welcome to bring their food waste. We're very happy to be here and are looking forward to this event.
Thank you so much. And thank you for being one of our perennial sponsors. So it's fabulous to have you here. Today is the Managing Challenging Organic Waste Streams in Vermont and Beyond session. And the format I just want to introduce is I'm going to be stopping sharing my screen in just a minute and sort of introducing this topic and how the session will be sort of unfolding. And then we have 4 panelists with us who I'll introduce, and each of them will have 4 to 6 minutes or so to sort of, further introduce themselves and explain how they relate to the topic at hand. And then this is really intended to be an open conversation. The session really came about in part because there have been a lot of concerns raised over contamination in compost. And this can take all different shapes and sizes and names, and it seems to be increasingly in the news. And so these include physical and chemical inputs that have industry professionals and citizens alike really concerned about what we're putting on our soils, right? We manage these residuals and we make compost often out of them and then land apply them. So what is in this? Whether it's PFAS, biosolids, microplastics, or just trash, non-compostable contaminants, the spotlight has been on preventing or reducing and just managing all of it. But the focus that we're seeing is often on trying to address these issues at the end point, right? On the composting side of things or at the residual side of things. And that can be really challenging because the root of a lot of these issues are, of course, further upstream, right? We're not creating these issues. They're entering the feedstocks and getting into our organic management systems from the top down. And so ideally, we'd be encouraging different decisions about the products we use and the systems we all have become so accustomed to living with in our societies. Simply saying that and trying to work upstream, there are some opportunities there and there are also some challenges there. And it's also a slower and longer process. So in the interim, while it's definitely prudent and makes sense to keep these residuals off agricultural land and other sensitive ecosystems, for example, simply banning them doesn't just like make them magically go away. I mean, if that was what it took, wouldn't that be fabulous, right? We'd be way ahead of where we are right now. And yet, we still need to think about what are we going to do with these materials as we're learning, as science is catching up, and as we're figuring out how, some better ways to do our jobs. So this session is really intended to be an open conversation, as I said at the beginning, as we consider what can we collectively do with some of these more problematic organic residual streams. Where can they be reasonably used, if at all? And if not, what do we do with them? Like, we have to do something with them. They keep coming, right? Every time we use paper or flush our toilets or, buy products, and it's, that may have some of these chemicals of concern in them, we're creating a waste stream or a residual stream from that. So where can they be reasonably used, or how can they be reasonably managed? And then, as I said earlier, I'd also, I'm hoping we can get into a little bit about some of the work that's happening upstream to try to make these organic residuals safer. And what are some of the limitations, or what are some of the challenges that we run into, at that end as well? And so this is really, we've invited folks who are working in the organic residual management, organic management stream to be in the room with us today. But it's, it's everybody's problem, right? It's not just on the end of this, right? This is something that we societally, collectively are creating perpetually and needing to figure out then how to manage. And so that's sort of the spectrum that we're hoping for today. And so I'm just going to introduce our 4 panelists and then invite them to make some opening statements. So Andrew Carpenter is a certified soil scientist, crop advisor, and nutrient management planning specialist. He has extensive experience in research planning and handling technical issues around the reuse of organic residuals. In 2003, he founded Northern Tilth, who some of you may be familiar with. It's an environmental consulting firm focused on organic waste management and building soil health. So just wave, Andrew, because I think your name is up there, but just so folks know who you are. Josh Kelly is the Solid Waste Program Manager of the Vermont Department of Environmental Conservation. The program oversees the regulation and implementation of solid waste management, including waste reduction, separation, collection, hauling, facility management, disposal, reuse, recycling, composting, and producer responsibility services. This also includes compliance, education, and enforcement work for solid waste and salvage yards, along with the development and implementation of the state's materials management plan. Josh has over 20 years experience as an environmental professional, having worked at the Institute for Sustainable Communities, the Highfield Center for Composting, and the Trust for Public Land. Eamon Twohig joined Vermont DEC in 2012, and in 2017, he started with the Waste Management and Prevention Division as the manager of the Residuals, Waste, and Emerging Contaminants Program. Chief among the duties of this program is ensuring that the beneficial reuse of residual materials, such as biosolids, is performed in a manner that protects the environment and human health. A major focus of the program is to assist the state with investigations and regulatory response to per and polyfluoroalkyl substances, PFAS, I never quite say that right when I have to say it all the way out, contamination in our environment. Prior to working for the state of Vermont, he conducted research at the University of Vermont, focused on reducing pollutant and excess nutrient loading to surface and groundwaters via innovative low-cost technologies, such as constructed wetlands and phosphorus-sorbing filters. And while Josh Tyler, who's the Director of Operations at Chittenden Solid Waste District, was on our panel originally, he unfortunately couldn't join us today, but Dan Goossen, a very capable stand-in who works with Josh, has joined in his stead. Dan Goossen started at Intervale Compost in 2003 and has been managing the compost operation at CSWD, Organics Diversion Facility, or Green Mountain Compost, as most of us know it, since 2008. Dan spends a lot of time with people and working with numbers, but is most happy at work on those occasions when he gets to climb a mountain of compost or spend the day screening a finished pile. And so thank you all for joining us today. And I'm going to invite Andrew to start us off.
Hi. Yeah, so I did put a little bit of thought into this. So as a company, Northern Tilth, our mission is to use organic matter-based byproducts to improve soil health while furthering the science of organics recycling. And we literally work with almost every type of soil amendment that can be used as a soil amendment, or waste product that can be used as a soil amendment under the sun. We work with people that are directly land applying materials, composting them first, anaerobically digesting them first, in some cases combusting them or pyrolyzing them. Just due to the nature of our work, we tend to thrive in the gray areas related to organics recycling. I feel like we never have the ability to just put on a white hat and say, we're recycling organic waste, so we're great. But we get a lot into chemical characterization of materials, refining application rates, and essentially making sure that materials are being used appropriately to both improve soil health and fertility, increase soil organic matter and carbon sequestration, while minimizing any potential risks to the environment. And so in that, we get into a lot of testing of sort of boutique chemicals and things like that before a lot of other people. I think we got into PFAS testing very early. We were the ones that identified some of the farms that do have very high levels of contamination in Maine that some of you have probably read about. And at this point, we've tested, or at least sampled for, and had analyzed hundreds and hundreds of samples of soil, compost, other soil amendments, water, and agricultural products for PFAS. From my perspective, based on the sort of our understanding of PFAS and where we're at this point, that I feel there's a really big need to distinguish between those levels of these compounds that can have a negative impact on human health and the environment when they're applied in the form of residuals, incidentally, and distinguishing between those and levels that actually can cause harm. And it's a dynamic science, it's changing all the time, so it's always impossible to exactly pinpoint that. But based on our experience and based on sort of the level of understanding, which isn't that high of PFAS at this point, I think a lot of people think most materials don't have any PFAS in them, and if there's something that does, then that needs to go to a landfill. From my perspective, it's the idea of only using our organic waste as soil amendments that are non-detect for PFAS or microplastics or anything like that. It's utopia, and it's untenable. It's something that's to shoot for down the road, but we're a long ways from that. From my own personal perspective, I would love to see, globally, us working towards more green chemistry and going through a vetting process when new compounds are introduced in the environment. And for me, like I just assume have a soggy food wrapper than have PFAS in it. I don't care about that so much. I don't buy into antimicrobials in soap. I think that haven't really been even clinically proven to be effective, and yet they're in everything. And polybrominated diphenyl ethers, we have them in absolutely everything to reduce the risk of fire, but I would take a little bit more risk of fire to not have polybrominated diphenyl ethers in everything that I'm touching in my house. But we're a long way from that. Even if we started today on that effort, we've got essentially a reservoir of a lot of these materials, typically in very low concentrations. We've got a planet that's burning up. And from what we can tell from testing, the difference between materials being non-detect, say for PFAS, And those that are detected at low levels is typically just the luck of the draw. Everything has the potential to have some in it. I think it's true with microplastics in a lot of settings as well. So I think it's really important for us to have these conversations for people to understand that, yes, we are exposed to some of these compounds in some of our waste materials, but to work sort of to effectively understand better what the risks are and not throw everything out the window just because there's a detectable level of PFAS or polybrominated diphenyl ethers or microplastics in them. I also find, and this has been true since I've been in the waste industry, as a company, we're agnostic in terms of technologies. We will work with anybody that's managing organic waste. But I have seen people, you know, in a case like this with PFAS or anything, favor technologies over another and start bad-mouthing each other. Anaerobic digestion is better than compost and vice versa. If we pyrolyze all our biomass, we're going to save the world from everything and cure climate change. Essentially, all of these have a place in managing organic waste. And to me, that's really important that we're all working together and not necessarily trying to throw other people under the bus in order to make ourselves look good, because it ends up kicking you in the ass, and you're going to find things that you didn't expect to find in your own materials.
Great. Thank you very much. Josh, Kelly.
Yeah, sure. I guess I'll be brief, but I will follow along some of the same comments that Andrew put out there. I mean, as a regulator of solid waste, we have both an obligation and statute to prioritize moving the state away from dependence on landfill disposal as a method for managing our waste. And yet we have also charges to protect human health and the environment. And balancing those and accepting some of those trade-offs is the challenge. And so I will be at this juncture at the Vermont Organics Recycling Summit. I'll be the first to say that word recycling conjures up some positive feelings for many people. But we, as a society, don't just recycle things just because it makes us feel good. They need to have a benefit, and they need to have a mitigation to their potential negative implications. So we're trying to balance the benefits to society from recycling something and to mitigate any negativities associated with the practice. And that goes for anything from scrap metal to right down to organics and food waste. So I think we in the organics recycling field have seen concerns that have upended the industry, damaged the industry, even in my own relatively short time in this industry, going back to PAHs in leaves was a huge concern there for a while, with mostly with urban composting or municipalities doing their own leaf and yard composting. I remember talking to Carl Hammer about that about 6 years ago at Vermont Compost Company. And then there was persistent herbicides. I remember talking with Dan Goossen about that even more recently, but still a ways in the rearview mirror. So there's constant emerging challenges in this field, and I'm not trying to downplay where we're at, but I think we need to learn from those lessons and to work with the industry to try and find ways to address them. We are not going to be turning our attention away from this organic waste stream as a focus area for reducing it in terms of how much is disposed. We're going to always be trying to push that into higher and better uses and away from disposal for the benefits that can net to society economically, environmentally, and socially. And so I think that's the North Star. We may not have the solutions to everything today in terms of these emerging contaminants. But we also need to, I guess we kind of, to Andrew Carpenter's point, we need to exist in the gray, and that's uncomfortable. We might want to ban all this stuff, don't use it at all, or if this has any material in it that's negative, it's bad. I think we need to follow the science, and also be cognizant that when we have in the past dealt with contaminants, I'm thinking of heavy metals were the traditional thing. Heavy metals and pathogens were some of the first common things tested for, both in biosolids and in food waste compost. And they were like, these are the standards we're going to meet. That was then. This is now. We're still using similar scientific standards to test things, and we need to do that on into the future. So I guess I just want to express from my department and my program and division in the agency that we will be continuing to focus on ways to use these materials. And the question is how and where and when is it appropriate? And that will follow the science and follow regulation. And it's not always an easy place to exist in the gray to deal with the trade-offs, but that is the job, and that is the needs of all of us in society. So I'll leave it there.
Thanks so much, Josh. Eamon.
Good afternoon. Josh, I thought you were going to be brief. Sorry, I have to start with a joke. I think it makes me feel less uncomfortable. So yeah, my name's Eamon Twohig. For those who don't know me, I work in the residuals management program at DEC, and we're operating in the gray, I guess, is the theme of the day. We're one of those strange programs that no one knows what we do, and we've got a strange title, residuals management and emerging contaminants, which puts us in a unique position of managing a challenging material that was challenging prior to PFAS, and by that I mean wastewater sludge. It's got a lot of negative connotations with it. When people find out what I do and I have to explain, give my 5-minute elevator pitch or my 30-second, it's really hard because I'm like, do you know what a biosolid is? And they don't, right? And most people don't, and that's okay. Or they think it's a general term that applies to all kinds of materials. In fact, it's very specific, and it's only treated sewage sludge that's set to meet a very specific standard set down by the EPA. And that was a very recent thing. That was from 1993. So we are operating in a world that is pretty new. And, typical with a lot of states, including Vermont, we would take those federal rules, which in our world are the EPA 503 regulations on sewage sludge management. And then Vermont would take those and do what Vermont does, which is improve them, make them Vermont level restricted, or, with Vermont's stance on them. So, most states' rules reflect the federal rules, ours do too. But my point is that I think that there's challenges to begin with this material in terms of it's gross, it's icky, it comes from poop, it smells, all these things, right? So then I think the world was starting to get over some of that. At least a lot of us who work in this field I feel like we're making progress on some social acceptance of that. And then enter the boogeyman PFAS, and it just blew the lid off of everything. And it was like you had to hit the reset button and start to think again about kind of going back to square one, and acknowledging and being objective enough to say, we don't know this, we don't know this, we don't know that. There's a lot of uncertainty, and we need to start figuring it out. So we've been doing that for several years now, and there's some good outcomes and some not so good outcomes. Some of the bad outcomes have been that we've had to close many land application sites for biosolids in Vermont because they were historically utilized, let's say, multiple decades, and that PFAS content has built up in soil and has resulted in potential leaching to groundwater above our standard. So the simple solution from a regulator is to close that. You start to see the snowball effect of when you start to take that option away as a recycling outlet, and it truly is a recycling process, where does the material go? And so that's what we're seeing right now in Maine, unfortunately, where that's a legislative prohibition. In Vermont, it's been more our reaction to data we have on the ground and trying to be thoughtful about how we're going to manage this, but we obviously cannot allow contamination of our groundwater in the state. So that's, again, we've already heard this balancing act of we have to look at the big picture. The material is being generated constantly. It's not going to go away. We can't shut it off. And it can't all go in a hole in the ground, and I mean a landfill. So, and you said that earlier, Natasha. So we have a real challenge, and I think it's going to take a lot of thoughtful steps to get us to a point where we can be. There's not going to be a silver bullet. There's not going to be one magic technology, as Andrew alluded to, perhaps, that's going to solve the problem. And we are probably going to need, this is a bit of my opinion, which I maybe shouldn't give, but we are going to have to live in a world with PFAS because it's here, it's in the background. And we need to be very careful about making broad brushstrokes that will eliminate reuse options for these organic materials for the sake of fear over a contaminant, when, as Andrew pointed out, we've got a climate crisis on our doorstep, or been on our doorstep, and building soil health, as everybody on this call probably knows, is a fantastic way to promote carbon sequestration. So biosolids and sludge might be a very small portion of that soil sequestration potential, but it's there. It's a piece, just like all the other food wastes and food scraps and other things that we do to build soil health. So that was my long-winded intro. Thank you for listening. Pass the baton.
Thanks so much, Eamon. Yeah, Dan.
Yeah, thanks for all the panelists who are joining this. I'm really looking forward to the rest of the discussion and learning from you all. And thanks for Natasha for the entire conference, but particularly this session. I think it's high on everybody's mind who lives in this world. And unfortunately is going to be growing, unfortunately or fortunately, growing in recognition for everybody who uses compost, and eventually there will be more and more people learning about these things that we'll be talking about, and wanting to know more as how it affects them personally. So a lot's been said, and I agree with most of that, and don't have a ton to add in that regard, other than maybe pointing out that I think we're at an important turning point in, let's say, like the last 100 years of organic residuals or organic waste management. We've made incredible progress. On the one hand, we're a week out, or a few days out, from the start of International Compost Awareness Week. Begins on Monday, and it's important to recognize the incredible work we've done both here in Vermont and New England particularly, but really across the country, to pull more and more things out of the landfill, recognizing the harm, the great harm of putting those in to generate methane that is often uncaptured. Biosolids, I'm going to skip that one for now, but it's, we're doing all this great work, and yet I think as we learn, the science is still catching up, right? And the speed at which we're discovering new information about all of these potential contaminants, and what historically have been, if you go back 100 years, there weren't problems with anything that was anything organic, anything that touched your dinner plate, or anything that got flushed down a toilet. You could use that without concern, pretty much. So maybe not 100 years, but a little bit beyond that. And we're at this point now where suddenly everything that everybody's trying to do the right thing, but it's not one, it's not two. There are so many inputs that we have in our processes, be it composting or biosolids, that potentially we need to be really worried about, at least more familiar about, as everybody's pointed out, they're ubiquitous. The more we learn about PFAS and microplastics, we know that the ship has sailed, that for many, many, many years now, these things have been pumped into our environment, into all of our consumer products, into our clothing, into the air we breathe, the rain that falls out of the sky, and have been causing problems for human health and environmental health for a long time in certain measures, and we still are not understanding fully what those impacts are, but we are just barely recognizing that they are coming into all these streams that should be clean. That if it weren't for industry and society and science and scientific advancement and all the chemical corporations who are trying to fix all of the, shooting for convenience and comfort, and if it weren't for all that, these things should all be readily returned back to our gardens to grow healthy food to feed our family. So I'm just underscoring the point that we're at this juncture where finally we're doing the right thing in big measure in terms of meaningful impact, in terms of reducing the amount of organics that are being managed the old way of the last 20, 30, 40, 50 years, and yet it's a tricky thing. So more than anything, I think the education piece is, the science has to catch up, but also the education piece really needs to catch up because it's complicated stuff. And from my point of view, as somebody who makes a product that is then is assumed to be pristine, as the whole compost should be in people's minds, when they find out, read a headline or hear a headline about it, there's a lot of alarm, and it's understandable because it's confusing stuff, and the human health impacts can be very scary. And so, yeah, there's obviously more questions than answers at this point, but I don't know. I think I'm looking forward to the rest of it. I will shut up now so that we can get a conversation about it, but looking forward to hearing what other folks have for questions and where we can go from here.
Thanks so much, Dan. And so hopefully for all the participants, you're starting to get a flavor for the level of nuance that we're hoping to achieve in this conversation. Very rarely are things black and white. And as Dan was just saying, like, keep these organic materials out of the landfill. That's great. Oh, there's stuff that we may not know about or may be concerned about in the organics. What do we do? Like it's this kind of like yo-yoing back and forth a little bit between really trying to be good stewards and figure out what the best thing is. And there's a lot of nuance there. And I think that in my experience, my limited experience with policy is that that's often, also a really challenging place to be because, I'm not speaking for the policymakers in this Zoom room, but my experience is like, wouldn't it be great to have a number? Right? Like let's boil things down to and there are some issues like the one we're discussing today that, we can't really just boil things down and have a simple answer. There's going to have to be a lot of approaches and nuance. So I'd like to just open it up and to see if any of the participants would like to share your point of view, ask a question, share sort of what brought you into the session today. So I'll let you guys think, and I'll also invite our panelists to maybe either have follow-up or ask questions of each other. One of the things that has been really challenging in terms of that education and helping bring communities and people sort of out of the industry up to speed on what we're dealing with is this lack of context or understanding what the ambient levels of PFAS are, for example, or microplastics. It could be other things. But like, so for PFAS, like if you get something tested and people are like, oh, it has PFAS in it. Everything pretty much has PFAS in it, like Andrew was saying, right? So like, but without understanding the context, is it below the ambient background PFAS in the topsoil? Is it really high? Like, of course, there's concern and there's really valid concern, but we need to get to a place where we can start understanding and not having just these numbers create an emotional reaction and have, which is understandable in the absence of information, but have more tools at our disposal to start understanding and also help educating the public in terms of what these numbers may or may not actually mean. And I think for me, from the composting industry side, I often get into conversations where like the focus is all on compost without any recognition that there's PFAS in our topsoil. and so maybe even adding biology into, with compost, with that, and making that soil healthier, you're still getting benefits potentially without even adding more than what is naturally there. So, yeah.
Well, I'm sorry. I was just going to say that
Go ahead.
it leads me to like a couple anecdotes related to that. And I do think that that's been the toughest thing for us working, because we have worked really extensively with PFAS now for 3 years as a company. I'm also I'm a board member of the Compost Research and Education Foundation, and the U.S. Composting Council now has kind of a PFAS task force that I'm on. And so we get concerns from composters around the country, but one of them recently was a composter that sold compost. A woman used it in a garden. She read about PFAS and compost and I think she may have taken the test herself, took a test of the garden soil, and lo and behold, there was PFAS in it. And called the composter and said, you've got to come pick this up. You've contaminated my soil. She did share with him the results. Is another thing, is there's so many different units that we use in looking at these that you have to look really closely at the results. So in soils, typically, results are listed as parts per billion. These were listed as parts per trillion, so they looked really high at first, but they were in fact right at the levels that we see as background levels in soils. But if I can see it from a consumer's perspective. We're just bombarded with articles about forever chemicals and how horrible they are. You hear of an association with that material in compost, and then you find out your soil after using it has PFAS in it, and you're outraged and scared. I think I think that's one of the things as a company we spend the most time on. The sampling itself, we got into it early, but it's not rocket science. It's really a matter of avoiding any cross contaminations, because ironically, it's in all the things we're wearing while we're sampling if we don't take care to take them off. The most time we spend really is on helping people understand what the results mean. And as I mentioned, we've seen the gamut, because we have found some really high levels of contamination on farms that have been really dramatically negatively impacted by it. But the bulk of the testing we do are in areas that are kind of around background levels, and that's just tough to explain to a lot of people.
Mm-hmm. Yeah, so we have a question in chat. Tom says, it's my understanding that PFOAs are migrating through soil into the water table. Is there evidence these chemicals accumulate in soils, and have they been found in food grown in these soils? I don't know if any.
I think any of us could take this one, but I'll stab at it for a sec. Yeah, generally, yes is the answer to that, unfortunately. Andrew cited a general concentration there at parts per billion, which is mind-bending for most of us to begin with. It's a very small amount, and that's typically when we're talking about materials, media like soils, residual materials, composts, but soils, I think, is the focus here. It's pretty common to see parts per billion level and very low. We're talking one part per billion to maybe 5-ish across the Northeast. So Vermont, Maine, New Hampshire, Massachusetts have all done background soil studies, and they're all available on the internet if you want to go read them. And they pretty much draw the same conclusion. So Vermont did ours in 2019. And that is that PFAS was in every sample, and it was at very low levels, and that's at a part per billion. When we talk about water contamination, we're down in parts per trillion. So we're talking way less, 1,000-fold less concentrations. Typically, you're going to find when we're talking about water, we're talking about parts per trillion. So what happens is the PFAS will accumulate, and for example, there could be a different sources, but if it's through aerial deposition, there could have been a release of some kind. Maybe there was some material that was spread on the soil, and it's basically accumulated there in the soil, and it will, depending on the compound, without getting too deep into the science here, these compounds, some of them are sticky, or might be more inclined to stick in that soil, and they'll typically be in that top layer. We might call it plow layer or something like that. But slowly over time, depending on the compound, and a lot of times PFAS come in as a family, as a group together. You don't just get one of them. You'll hear people refer to them as PFOAs. PFOA is one type of thousands of known PFAS chemicals. So depending on how big the compound is and with its polarity and things like that, it will readily migrate to groundwater, or it'll stay in the soil for a long time. They're called forever chemicals for a reason. So you get both. You get, accumulation in soil and potential leaching. The pathway from soil to groundwater is not well understood. The USGS, the federal level, and New Hampshire DES are working on a project right now to try to clarify that pathway. It's complicated. It requires a lot of modeling and a lot of testing and a lot of field experiments. I think they're on year 2 or 3 of that project. There is a lot of data coming in from Maine because they do a lot of testing in Maine. We've got a lot of data in Vermont too that corroborates that, yes, PFAS can leach from soil to groundwater. It can also go the other direction into crops. And again, we are in the very early stages of understanding. There's so much variability between what the PFAS compound is, what the concentration is in soil, what type of crop you have, what part of the crop are we talking about, the stem, the stalk, the fruit, the leaf, and we just don't know enough yet, I think is the short answer after all I've said there. And even some of the studies are so focused on one specific type of PFAS that you're just basically looking through a keyhole, and you really, so we just really don't have enough information other than to say, yes, it can happen. We just don't know under what these conditions are that are making this occur. So good question though. Thank you.
Can I add just a little bit to that?
Please.
I'll try not to dominate the conversation. It is, so as alluded to at the beginning, we've, as a company, have looked into a lot of different compounds and types of compounds that occur in different residuals. And it is the case that PFAS has been by far the most complex. And the reason for it is this. Typically, if you look at some of these persistent organic compounds like polybrominated diphenyl ethers or fire retardants or dioxin, PCBs, they're persistent, so they have long half-lives. They stick around in the environment, but that quality also means that they don't have much mobility in the soil. They absorb very strongly to both organic matter and solid soil particles. And then on the other end are things like volatile organic compounds that move around, have higher solubility, but tend to have a shorter half-life, so they don't exist as long. PFAS is a horrible combination because it has a little bit of both. And it does change a lot from any of the thousands of compounds that are out there. Some are more mobile. They have a long half-life, and some of them are, in fact, taken up by plants. In Maine, just by virtue of having had to look into this a lot, there's a fair amount of data, especially that the state has, the CDC, but it does tend to be the case from what we've seen that one compound, the PFOA, seems to be more soluble, have higher potential leach to groundwater than, say, PFOS. And these are the two that we've looked at the most because there's the most information out there on them. They do have toxicity associated with them. PFOS, on the other hand, doesn't tend to leach as much, but we have found that there's a pathway, especially in the highly contaminated soils, from soil to grass, especially, and from grass to beef or milk. And we've also gotten to the point where we understand some crops have a much greater propensity to take them up. Grass happens to be one of them. Fruits and grains, you don't typically tend to have a lot of uptake of them. But we're still, like Eamon says, we're still at the very sort of beginning, the triage stage of figuring these things out.
Thanks, Andrew. And just to broaden the idea of PFAS in our food, I also want to just point out that growing things in soil that may be contaminated is only one of those pathways, right? We have PFAS actually in a lot of our food packaging. So it's so easy to be focused on this one pathway and have reasonable concerns about that. But at the same time, we're concerned about this, and we are choosing and allowing to have PFAS in packaging that can also contaminate food with it just by the virtue of proximity there, or putting it on our skins. But we don't want to grow something to eat it. And I'm not saying that any of it is good. I'm just trying to remind folks that this is actually a broader issue that touches on a whole lot of different levels. And so while we're asking questions about, soil to groundwater, soil to food, and uptake, it's really a broader conversation in the context of this broader conversation that needs to be happening culturally, societally, right? So Tom, I was just going to read this. Tom had asked what the background level is in people, and Eamon said that there are studies of PFAS levels in blood, but he didn't have the reference handy, and it depends on people's exposure.
So
and
I
Andrew,
I have a couple of references for that. We've been working on background levels. So it'll take me just a second to bring up, but I can tell you that if you just look at PFOS in our blood serum as a general population 20 years ago, so around 2000, the average level in the U.S. population's blood was about 35 parts per billion. Because and PFAS was lower than that by maybe 3 times. But because those two have been phased out, we've seen the blood serum levels in our population go down considerably. So now PFOS in the general population's blood, if you haven't been exposed to it through a workplace or something, is typically around 5 parts per billion in the blood serum. So it's a 7-fold decrease since then. It's been the same with PFOA in blood, although the levels were lower to start with. But so there is, and I don't know if there are people that actually have blood that's not detected for it, but basically we have this background body burden of it as a U.S. population, and all populations are going to have something like that. So it has gone down for those 2 compounds. It's unclear with other compounds that may have been substituted, how much change there's been, or what other levels have done.
To follow up on that for a second, and what you were alluding to, Natasha, I think it is important. I think probably a lot of people joining us today are aware, but in case they're not, that the levels in the background soils and in soils that have had biosolids added or compost added, unless it's been an industrial, a point source industrial problem area, such as some of the places in Maine, generally the soil levels are still lower in often cases than blood levels, the background level. How much fluorinated compounds could be tested in human blood, and even more important, perhaps, are all the very many pathways by which humans are interacting with these chemicals on a regular basis that have nothing to do with soil. So it's not just like the fast food wrappers at McDonald's, or which are, and hopefully Josh can remind us all what that pending legislation is on food packaging in Vermont in a minute here. But there's also cosmetics, like things that get flushed down our wastewater systems, our foundation, mascara, lipstick, rife with fluorinated compounds. All of our Gore-Tex and other water shedding clothing that we love so much, that allows us to be comfortable in rainy conditions and in the winters here, chock full of fluorinated compounds, carpets, our furniture, And then there's some really, really high levels in other specific areas that are very problematic. We've heard about them in the news in southern Vermont due to like Teflon manufacturing, and anywhere where firefighting foam has been used, particularly at airports and Air Force bases and that sort of thing. It can be really, really high levels, but it's widely available in our lives, and so it points to that really strong need of more controls upstream before it gets to those of us who are just receiving the material and are forced to choose what's the best pathway to deal with it. Meanwhile, we're all consuming much larger quantities of it than what is in the typical background levels around us, even if it's in the soil at all.
Thank you. Josh, did you want to give us that reminder a little bit about some of the work that's happening now at the state level around food packaging?
Yeah, sure. I was actually just typing in the chat and trying to get links to the statute, but in short, this is laws that are looking upstream, that are really under the Department of Health's jurisdiction. But as of July 1st, 2023, this coming summer, intentionally adding PFAS to food packaging will be prohibited in the state of Vermont. So the Department of Health is beginning to work on rolling that out. And then, this greater conversation of biosolids and sludge, we got to ask ourselves, where does the PFAS come from? And it's coming in a residential context from our washing machines, primarily in our own cleaning activities, but primarily washing of clothes that are dermal contact. So that is constant. And I'm not trying to just say, oh, just throw up your hands. You can't deal with it. It's just everywhere. But you also can't assume that we can, as a state, simply manage all of this stuff through disposal. I mean, I look at the articles coming out of Maine and some of the commentary about landfill engineering, the actual straight up engineering of landfills, which is decades old, and yet they still haven't figured out a technology to handle a landslide of sludge, essentially. The sloughing off of slopes. Landfills is, instead of creating more land area to cover them, they go up. And that means they need slope stabilization and special compaction. And you can't do that with liquidy sludges. They're very, very difficult to manage. And I think in Vermont, some of the silver lining here, and Eamon might be able to talk more about this because he's connected to wastewater people in the department, is some of the ARPA funds are being invested back into infrastructure. We've heard about this a lot. And one of the things that even if we're going to have a disposal model for some of these sludges, drying them is critically important. Whether you're going to land application or, anything you're going to ship, you just don't want to be shipping heavy water if you can get that water out. So there are some things we can do to minimize the waste, essentially, regardless of its end destination. So I guess these are small concessions, but things we need to keep in mind as well as ARPA funds are going on, by the way, and not just in Vermont, but obviously across the US right now and being used for these types of things.
So Deb just asked, she just wanted to double check. There was mention of washing machines being a major contributor to PFAS, PFOs, PFOAs. Did you mean microplastics? Anyone want to?
Josh said it. Josh, what did you say?
I'm sorry, I was trying to get off mute. I was talking about PFAS in that situation. I was going back to where Natasha was earlier about different pathways. So in that situation, talking about washing machines, yes, I was talking about PFAS. But yeah, in this conversation of emerging contaminants, you can't ignore microplastics either. Mm-hmm. And yet I've heard of different solutions like filters on people's, my dryer has a filter and I throw away that lint. I don't compost it, as some might suggest. I think we need to have a reckoning with our use of these materials and how they benefit our lives and how they impact our lives. And until you take that broader picture, because we have no choice as waste managers but to look broadly. We can't rocket this stuff off to the moon as much as we might like. It's a tough trade-off. Anyway, I'll hand the mic back to Eamon.
Yeah, and I think one of the trade-offs that comes to mind whenever I think of what we're doing is the concept of exporting waste and recyclable or potentially reusable waste is one that's always bothered me, and having to put things on trucks and send them great distances just to be able to manage them. And I think that that's something that sometimes gets lost in the conversation, because people say, oh, you put it in the landfill and it causes climate change and it takes up space and the walls of the landfill fall down and whatnot, right? These are problems. But the bigger problem in my mind is that you take a material that was generated by the folks that live here and we put it on a truck and get rid of it. And it's maybe not my place to say this, but the whole not in my backyard thing, it's got to stop. And we can't rely on shipping things away to let somebody else manage them. I mean, if the market dictates certain things happen and waste need to move a little bit distance, I understand that. And we could talk about recyclables, and Josh could tell us all day how far recyclables go. I mean, they go to other continents, right? And the same with our used clothing that ends up, in piles in other countries. We can't continue to rely on trucks as a way to get rid of our waste and go, well, it's gone now, let's move on to the next thing. And that's easy to do, especially in a New England state. We in New England tend to ship our stuff to other states that'll take it. And that's just, it's not gonna, when you look at the climate picture and putting more trucks on the road to move, as Josh already alluded to, water weight, it just makes you shake your head. What are we doing, right? And yeah, absolutely. If we can dry our biosolids to 90%, and you're managing, your typical percent solid might be 25 to 30, that's 60% less volume to move and weight. So it's a significant change. And, in Vermont, we are limited in what we can do. We don't burn things here. Other states burn trash to get rid of it. They burn sludge. And so the thought of Vermont exporting its sludge to an incinerator down in Connecticut, I don't think any Vermonter wants to hear that. I don't think that that's a Vermont way of dealing with things. So I'm getting a little bit philosophical here, but I didn't know where else to go.
Well, to your point, Eamon, though, I think that is it's an waste management, and this whole conversation around waste to resource, like what are some of the things that are in our waste streams that could be seen as resources. This is all part of the conversation in my mind around community sustainability and self-reliance, right? And it can be a little uncomfortable piece of that conversation, but it is still part of that conversation. If we're producing it, can we figure out how to effectively manage it, in-house, so to speak? And there's a lot of different ways and scales that could be done. Tom in the chat says, as a compost facility, does this present a disincentive to accept food scraps and leaves with BPI plastic or plastic bag contamination?
I'd be happy to take a stab at that. Yeah. I think yes is my quick answer to that. I think we are learning more and more every day about what is in these products. And there have been some substantial changes in the industry, and people are aware to a degree about the dangers of fluorinated compounds being added to compostable products specifically. So just real quick on this, the food serviceware that people see that are labeled biodegradable or compostable, a lot of them are, so they come in my mind, two types. There's usually the ones that are fiber-based and the ones that are bioplastic-based, perhaps, that are using a mostly non-petroleum adjunct to make their product. But the fiber-based ones, historically, those are sold in areas where the manufacturers are trying to achieve a product that is going to be rigid and usable, even if it gets a heap of sloppy Joe, a sloppy, whatever the food product is on it, or a greasy pizza. So they're designed to resist water as well as grease. And what has happened in the industry is that they've, this amazing family of chemicals that we're talking about as being so problematic, that they serve a really important purpose historically for achieving those goals. But as we learned how bad they potentially could be particularly in the food in areas where there's a direct connection between container to food to mouth and human input, that they're scrambling to come up with potentially different for keeping those plates dry, or as Andrew suggested, maybe making it okay that your hamburger wrapper is a little bit greasy. But what we're learning is that it's not just, well, stepping back. So BPI is a big organization out of New York that regulates compostable products, and they said in 2020 that anything over 100 parts per million of total organic fluorine was no longer going to be approved as compostable, it's approved as a BPI approved compostable product. And so that instantly a bunch of things got thrown off their list of things that previously were approved as compostable. And there are many manufacturers are trying to achieve those limits. But there's, as was alluded to before, we've talked a lot about PFAS and PFOA, but there's thousands of fluorinated compounds of which we know very little about, and some of them are precursor to if they're in the environment long enough, they do break down into other fluorinated compounds and could be potentially more damaging to human health. So anyway, so there's some progress in terms of recognition and avoidance of some of those materials in some of the compostable products. But I would, as a composter, we at Chittenden Solid Waste District made the decision a year and a half ago that we didn't want any compostable products coming into our system, with the exception of the plastic liner bags. So no more fiber products. And we give that recommendation to other people when they ask. And it's tricky because everybody wants to not use plastic. They want to not use styrofoam. And so it's important to have some alternatives in some scenarios. But we push back and say disposable single-use products in general are not the answer. We need to work harder and come up with better solutions. And the last thing I was going to add is that we're finding, as we find out more about paper in general, there's more concerns. The things that are even paper products that are not designed to resist water or grease sometimes have been, we're learning, problematic because it's a surfactant in the process of creating paper. Sorry, I don't know how to turn my new phone off. I will end there so I can get.
Yeah, thanks, Dan. I guess I'll just add that although folks may think that this is a small part of the solution, I think it's growing, and I think that really supporting on closed loop local decentralized local food systems is part of the solution here, because we know that we can make, if we're buying less, if the majority of the food that we can buy is local and comes with less packaging and not those damn PLU stickers on them all over, one per banana. So you end up with like 18 if it's like, right? Like there's this, on the one hand, you go to stores and there's this like redundant packaging system that you can see there. And then you can also go to, a farmer down the road or a farmer's market. And I just feel like that is often overlooked because it feels small scale, but it is growing in popularity and it is growing in power in terms of many of those, right? So while it may be a small scale solution, you multiply that by all of our communities. And I think it can have a meaningful impact in better and more responsibly managing the food scrap part of it, right? Or making better decisions or using durables instead of single-use products. That's the food packaging, food system piece of it that doesn't really get at the cosmetics and the ski wax and the, all of these other things. But in terms of especially in terms of composting and the impact on compost facilities. The Composting Association of Vermont is working with farmers to take food scraps from their CSA members, for example, or customers at a farmer's market. So folks are bringing their food scraps, often the scraps left over from the veggie share that they just picked up when they pick up their veggie share. And it creates this very small, localized, closed loop system that we can feel good about composting and putting on our, on our gardens and on our ag land. I see some links have been shared let's see, Mike says, green screen is supported by the Center for Environmental Health. No regrettable substitutes for what is being used as a grease and water barrier in food service packaging. And he provides a link. And I will be, we have some links on the CAV website that I can share out with the recording of this. And if anyone shares links, or like Andrew, you mentioned a couple publications, if you want to get those to me or links to them, I can also share those out so folks have reference to them afterwards. Yeah, and so I think, and folks feel free to keep putting things in, but one of the things that I was hoping that we could talk a little bit about in this session as well is use of compost and compost-based products and what that might look like and what are some different scenarios. And one of the conversations that I've been having recently around this topic is this, like ag soil often has repeated applications of a soil amendment, a compost, and there can be a cumulative effect of things. And then there are other sites that might be more industrial scale where we're, revegetation. It's sort of more of a one and done. We want to get plants back in the soil. It'll be covered, have their roots help stabilize a bank so it's not sloughing off. Potentially industrial sites already may have higher background levels of PFAS, just based on the activities that are happening there, not necessarily across the board, but that is something to look at. In my mind, I feel like there is a difference between the sort of multiple applications and sort of a one and done type of approach. And I would love to hear from our panelists if you agree with that, if I'm overlooking something or some pathway, or if that's just not the right way to be thinking about things.
I'll speak to that a little bit. And yes, I think it is good to recognize that those are different. But I think the difference is more not necessarily cumulative effect, but the fact that you're doing something at one time and you can know exactly what's going in at that one time on a one-time application versus something that's occurring over time. Because one of the things we've seen at land application sites is for biosolids is that it's clear if you look at the records. I mean, there are a lot of sites that have a lot of records associated with them, so you have a pretty good sense of how much material went down. You can do a mass balance. Levels of a lot of these compounds, just like they were higher in our blood 20 years ago, they were higher in our residuals 20 years ago. And so you can't necessarily do a mass balance based on today's levels and know what happened over a long period of time. Now, that's not to say that that's bad. I mean, it's just the nature of it. But if you're doing something now and it's a one-time application, essentially it's static in nature, if you know what I mean, in terms of chemical composition. There is, PFAS, everything about PFAS is complicated. There is, I think someone made reference to the fact that some of the compounds that we're not necessarily testing for, PFAS compounds, are precursors to some of the ones that we do test for that we have more concern over. So that is dynamic over time.
That's a good point. Yeah, that's something I hadn't necessarily thought of.
And I wanted to add something philosophically, because I know we wanted to talk to a little bit about, I mean, you're directing it back to use, which is great, but just wanted to throw in that I do feel like, I mean, it's great that Vermont's working on a packaging banned or whatever, exactly what it is, I'm not sure, but that's great. I mean, I think we really do need to go upstream, and in Maine, they did implement some kind of ban on PFAS related materials or products. But interestingly, there was the ban on land application of biosolids that took effect immediately. And the ban on PFAS related things in consumer products isn't going to take effect for quite a few years. And to me, to some extent, that's backwards, because we're essentially demonizing the waste materials that do, a lot of them have potential for us to use for soil health. And frankly, one thing we haven't talked about is, in terms of landfilling, the methane that is generated during that process is extraordinary, especially on organic waste materials, and that goes off in the atmosphere. It has very high global warming potential. But I do feel like we need to focus on getting these things out of our consumer products and not making them in the first place. And because it's going to be a long time before the environment's clear of these materials, but it seems like those are things we need to start on immediately.
Yeah, and before I go to the comment and question in the chat, I'll just tag on to that to say, like, Andrew, you shared that, certain things that we did stop using, the concentrations in our blood, for example, have decreased over time. And so, like, there is maybe hope if we can start getting these out of out of our environment, that there will be some recovery there, even though they're the forever chemicals. The impact that they have will decrease over time.
I think that's great to point out, and I think we have success stories we can point to. In dioxin, it's the same. Once we became aware of how it was formed, the levels that go off into the environment, and now our background levels in sediments and things like that, are so much lower than they were in the 70s. But I guess there was a comment about regrettable substitutions, and I think that's a big thing. It's like, so we catch up on PFOA and PFOS and in our bloodstream, so that is a success story. But there are compounds that have been designed to replace those that also haven't necessarily gone through the vetting process that would make sense for them to go through. Yeah, good point. So Tony in the chat asks, so is the main concern with compostable plastics the PFAS, because the requirement for BPI is measured in total organic fluorine so that it tests for any fluorinated chemical of concern? And for microplastics, like the great presentation from UVM yesterday pointed out, compostable plastic contamination was not seen in the compost. Seeking to understand composter aversion, not to start an argument. Is what in the chat. So
I'll follow up on that one. So our concern, our facility stopped taking compostable products, the food service ware primarily. It was actually not due to PFAS concern primarily. That was secondary. We were just getting so many contaminants coming in, and it was hard to differentiate visually between the compostable products that were okay, maybe, and then those that were not. We differentiate also between fiber and the compostable plastics. The fiber has been the ones that have been of most concern in terms of PFAS, certainly to this point, and for the reasons I brought up earlier, in terms of, you have a porous material that is going to absorb water and grease. You need to treat that if you were going to sell a commercial product for all those applications. So that's the one of concern. And in terms of the threshold that BPI has chosen for total organic fluorine, it's great that they're looking at total organic fluorine. It's much easier to test for total organic fluorine. But just for perspective, their threshold, I think, is 5 or 10 times higher than what it is in Denmark, which is the most restrictive for any intentionally added fluorine into a food product. And there's a reason that Denmark's there. Like maybe are they too restrictive? I'm not sure, but I think because of the fact that the thresholds for regulations in groundwater and soil and so forth are at parts per trillion and parts per billion, perhaps. The fact that 100 parts per million is where they're starting with is if there's other fluorinated compounds that we learn down the road are regrettable substitutes, that's why we're staying away from it, I guess. Now that we know more about molded fibers, particularly. I don't know if that answered that completely or not.
Yeah, Tony says, great, thank you. And Ben Gauthier also pointed out in chat that one possibility as well, that it was that the compostable plastics weren't found in the UVM research, is that many Vermont compost facilities don't take compostable products. So even if some sneak in, there's just a less, there's fewer of them to start with in the product, in the feedstocks. And so that does impact, and both Katie and Sarah did point to that in their presentation yesterday about the dilution effect. And so just keep that in mind as well when you're thinking about all these things. There's so much dang nuance, right? I mean, there's just not a straight line from A to B.
I also, one follow-up, I want to make sure I'm not maligning molded fiber, compostable molded fiber versus other, non-compostable traditional fiber products are certainly just as bad in terms of fluorinated compounds, and probably much worse because they're not being pushed to take out the most dangerous ones that we know about so far. It's just that in order to get that special stamp of approval, they need, that is important to some segment of the population, and for inclusion in composting some places, mostly not Vermont, that differentiation is there.
One thing that I've been trying to learn more about is this concept of a certification. I think it's a good idea in theory. It speaks from the standpoint of, it's the legislature or state can ban something, and they could try that angle. We've also seen the pressure from consumer advocacy groups on food packaging, for example, and you don't want to get on so-and-so's list of the worst food packaging offender if you're McDonald's or KFC or wherever you are, maybe, or maybe you don't care. But this sort of certification process is really interesting because it does allow folks to then, not only are you educating consumers, but you're giving them a choice to make a decision, right? So this is one way to tackle consumer products, because PFAS is ubiquitous in its use, and works so well in so many products that it's in so many things. So it's hard to just say, you can't bring it in, it's done, like no more. It's easy to say, but it's hard to do. So I think the concept of certification is a good one, but then what are those standards? And someone pointed out, the 100 ppm total fluorine standard in BPI. It's one thing to say, great, I bought a BPA certified product, but from the PFAS standpoint, maybe it's not so great. I mean, maybe it's a good thing, but it's not a great thing. And you could say the same thing about other certifications. There's an apparel certification called Blue Sign, where they're attesting to the fact that your Gore-Tex jacket that you bought from somebody, and maybe it's not Gore-Tex, could be anybody, North Face, Patagonia, you name them all these big companies, sports outdoor apparel companies, have agreed to do the certification, and you get the little tag and you could see it on your jacket before you buy it. And it'll say right on there, PFAS free. Well, it's not PFAS free. It's PFOA free, right? Or it's PFOS free, as Andrew alluded to earlier. There's also another opportunity there in how it was made, who made it, what were those worker conditions, so there's this opportunity there to get PFAS into that sort of a list of a more sustainable product that at least you give a consumer a choice to make, right? You go right now to buy a Teflon pan, they'll say right on them, PFAS free, right? Are they? I don't know. They're probably PFOA free. Do we really know? I mean, there's this level, but at least you're seeing it now. You're seeing it in products. You're seeing it advertised. You're seeing it as a way for them to promote themselves. Hey, everybody, I got a cleaner product over here. I think that's a really good thing. I think that's something that we can promote and get behind as people who are just sometimes feeling like, I don't know how to stop me from being a source of PFAS, right? Take away large industrial point sources. We're still left with all of us buying things and using things and contributing to a problem that we want to fix. And every day we're still contributing to it. So how do we start to twist that source down. And I think this is a way to do it. It's a way to educate people. It's a way to hold consumer products a little more accountable. And it's a way for them to make a success story out of it for everybody by saying, I did this thing, I bought this product because I knew it was a better product. The question then is just who's certifying them? And is that certification actually worth something, or is it just talk? So I think that's my final thought of the day. I know we're coming up on the 2:30 business here. So thank you very much for letting me be here. And this has been great. So I'll let the rest of you take it.
Thank you so much, Eamon. I'm just going to read a comment from Heather Voisin in chat. And then, yeah, I'd love to end with having the rest of the panelists sort of have final thoughts. So Heather says, in the same vein, having standards with numbers is key to being able to know how much contamination is reasonable to accept. So yeah, it's very much echoing the idea of like a number is only a number unless you have some context within which to interpret it, right? And start putting bounds on that. But we have about 7 minutes left. Andrew, do you have any final comments just to put you on the hot spot, or any Josh or Dan, you guys can go?
I do, and I'll try and be short. So it just philosophically speaking, it is, I do feel like this is recycling different types of organic waste to soil to build soil fertility, sequester carbon, and reduce the need, at least to some extent, for commercial fertilizers. It's kind of my life's work and mission. And I remember there was a guy that came to our school when I was in college, which was a long, long time ago, named Kirkpatrick Sales, who was a bioregionalist. And he was talking about this idea of like, you've got these cities and they're people eating and they're shitting and creating all this great fertility. And then you've got, you got to go out to the country where it's being grown, and they don't necessarily have access to that. They're throwing it away. It makes so much sense to bring that to where the food is being produced. Anyway, for me, it was a little bit of it's not wasn't an epiphany or anything, but it's like, yeah, it's sort of been a driver for me. But it is true, like I said at the very beginning, everything that I end up working on is sort of a gray area. But I think it's really important to keep in mind that, yeah, it's really important work to find out what we can do to utilize to the best advantage the organic waste that we as a society are creating. And I think we're, at a point, especially with PFAS, and it's going to be the case with microplastics, and things are going to come up after those, that we are able to sort of dispassionately look at these things and be able to deal with them. I know it's hard, risk assessment's really hard and all of that, but we can't simply determine that anything that has any level of something needs to then go to a landfill and take it out of circulation. I do want to say that I have seen instances of a lot of high levels of contamination that have been very damaging, but I think we still need to keep our eye on the idea of going upstream, cleaning up our waste, but also having some acceptance of the fact that our waste materials are contaminated with those things that we use in our everyday life.
Thank you. Josh, do you have any final thoughts you'd like to share for the session?
Oh, it's tough. I think what Zach put in the chat is pretty exemplary. And I think the precautionary approach gets tossed out a lot. And I wish I had the luxury of embracing it wholeheartedly. I just don't. I mean, even in my own life, I have a car that uses fossil fuels. I don't quite have an electric vehicle yet, and even then my grid is outside of me. So to apply the precautionary principle to everything is life limiting. It's not life affirming. It's actually life limiting. But that's not to say that it doesn't have a huge value to our approach. And so what strikes me is who is here in this meeting. There's a decent amount of industry in this session, and that is regulated by people like Eamon and myself and our broader programs and staff in those programs. And there is this constant balance between promoting and seeking entrepreneurs or municipalities or serving a public good to do this work that we're asking them to do, and then also regulating the activity to limit those externalities, those impacts to the environment. But I remain hopeful and I remain optimistic based on that the challenges that we as a industry and as a collective have overcome in the past when we've had a contaminant issue. And I also just note that the industry that is perpetrating these chemicals isn't here at the table today. And so that's a missing voice in this conversation. And I just think that we just all need to feel that absence of that entity's not here at these very small scale conversations, and they need to be part of it. And I think some of these laws that ban materials and products help make that go upstream. But as Eamon said, one of the bright spots is public awareness, because I'm aware that even a law that bans something is not necessarily as powerful as consumer demand. We don't require organic food be fed to people in Vermont, and yet the organic industry is a major player in the consumer culture in this state and other states, and it is just growing by leaps and bounds every year. So I guess my point is that raising the awareness is part of the broader puzzle to solve all of these externalities and some of the gray areas we're existing in. But I really appreciate the time, and I appreciate those that are listening in and putting their shoulder to this problem.
Thanks, Josh. Dan, any final thoughts you'd like to share?
Just another appreciation for being able to have the conversation. I think it's great that we have the forum to do that, and it's not, often when these things come up, they're in small meetings with people who are in the know, and so being able to connect with other people who are still learning about it, or who have different perspectives, or who have different information, it's good to come up with more of those. So hopefully, I don't know if it's the the Composting Association of Vermont can do more forums like these, short of our annual get together like this, but I think that would be great. And I'm sure there's other places in the state where we can continue those conversations. I agree with Josh that excuse me, it's critical that we further the discussion and educate the greater populace, because it's if we don't, we will have those knee-jerk reactions, and biosolids will start loading up in trailers all over the place with nowhere to go, and we won't be able to sell compost or keep these things out of the landfill, because it's a very easy one to have a knee-jerk reaction to, because of the complexity and the lack of information, really. And so yeah, I don't know how we all get together to do that well and timely, but it really needs to happen.
Yeah, thanks so much, Dan. And for everyone, I just put in chat a link to a conversation, a compost conversation that Cav hosted last August, September timeframe about PFAS, and there's links to all kinds of different resources, many of them Vermont focused, but also some external to that. So hopefully that'll be helpful to some folks. Thank you to our panelists for joining us today and sharing your expertise and perspectives. Thanks to all of our participants for your interest and sort of being able to, sort of allowing us to have these conversations, as Dan said, that often happen sort of smaller group or one-offs more publicly. I think that's a really key piece, to be able to have a forum to have these somewhat uncomfortable or gray area conversations to help more people understand the issues that we're struggling with, in the compost industry right now, and or organic residuals management industries. Thanks again. Much appreciated to everybody.
Thank you.
Thanks. And thanks, Dan, especially for stepping in last minute. Appreciate your time.
Thanks, Natasha. Good seeing you guys. Good seeing you, Andrew.
No, thanks a lot.
Thanks,
Bye.
Eamon. Thanks, Andrew.